Hello and welcome back to Calculus 2 section 6.6 on surface area of revolution. Now, parts of the title are missing. So, what is this all about? Remember we did the rotation for a disk and shell method. We were able to create objects which had circular base. We obtained those objects by rotating a function around x or a y-axis. And we use those two sections to calculate the volume of the object. Now, I am going to use this section to calculate the surface area around the object, excluding base, and if it has a top, excluding the top. Why do I need that? Well, maybe you need to give that surface area to your art design team to come up with labels and art design so your product looks half decent so someone might buy it, right? So we would like to know the surface area, also how much paint you need to, paint. Now you're going to say, yeah, just dip the, paintbrush and just paint the one. Yeah, but generally you produce like 10 or 100,000. So you kind of want to know how much paint you need to order for 100,000 pieces. So, again, surface area of revolution, we are looking at some kind of a shape that you get by rotation. It's still between A and B, and you still have the radius to be given by whatever function f of x you have in the xy plane. You rotate that, and you get your rotational shape. We talked about it. If it's a horizontal line, you get a cylinder, right? A tube. If it's a slanted line, you get a cup, right? Or the lampshade, as you mentioned before, which I'm happy now that I can use. And we talked about the baseball bat, the light bulb, and a whole bunch of other stuff. So now we are talking about the surface area of what is wrapping the object, again excluding these flat portions at the end, right? Those are circles that you can compute and just add if you need that as well, right? But the formula does not include those. So now what is the formula? Surface area of revolution is denoted by letter S rather than letter A. So just S equals, and it is the 2 pi. We have a rotation, so it's going to be 2 pi. And then we have our A and B on the integral, which are our limits as always. And now, inside the integral, we have f of x times the square root of 1 plus f prime squared of x dx. So you can see already the length of curve, right, playing a role in here. You can also see extra f of x because length of curve is 1 dimension times f is 2 dimensions for surface area. So we do have a formula that is 2-dimensional. And we also multiplying by 2 pi to add that rotation and roundness that we need because all of the objects are round that we are computing using this method. And this is obviously for rotation on x. And we box this one as our boss equation. Now, we also have the y version, which is 2 pi c to d, f of y, square root of 1 plus f prime squared of y, dy, rotation on y, another box on that, and the theoretical part is over. Now we'll do 1 or 2 examples and call it quits. Your homework for section 6.5 and 6.6 on MyMathLab is already posted, and it's due, I believe, next week at some point. Maybe, I don't know, you guys can just log on and check, but I know I posted it today, February 9th, which is next month. So yeah, you got 10 days or so. Do not get behind. Right? Next week we are finishing chapter 6. We are starting chapter 7 next week. So following week we are done with exam 1. I know. And I will be also posting the lab so you can enjoy that as well. Right? That will be on Canvas in the appropriate folder. Let's take a look at the example for this bad boy. Here is a vanilla example, problem 12. We'll do 2. 12, y equals x squared over 4 on 2 to 4. And clearly we are rotating on x because it's an... Oh, no, actually, we shouldn't say clearly because I just made a mistake. They're rotating on y. These are x limits here. I'm going to change this to 2 less equal than x less equal than 4 so you know what's going on. All right. The graph. Since we are only using 2 to 4, which is in a positive quadrant on x-axis, I'm going to draw the x squared function and let's say 2 to 4, which is this thing. We're going to rotate that on y, and if I'm rotating on y, I must use dy integral, and if I'm using dy integral, I have to have everything as f of y. So that means that I have to switch my function, right? I have to switch my function. Now, this is a terrible example as a first example. Yeah, I don't want to experiment, so let's just do it. So, about y-axis, yeah, okay, good. So, this is 2, this is 4, and we can calculate these points. When you stick 4 inside, that's 16, that's a 4, so that's a 4, 4. And when you stick 2 over there, becomes 2, 1. Now, I have to calculate the surface area. So this is going to rotate around y-axis. It's going to create another shape on the other side. There's going to be, right, a circle on top. This is a terrible example. I really need a different example, because what kind of shape are you getting here? Yeah, what's the surface area on the outside? It's just a flat cylinder. It's just this. So circumference of the base times the height, right? So this might be a mistake in a book. They might have wanted to rotate this on x-axis, which would make much more sense, right?
What do that instead?
Well, I don't know what kind of horror I'm going to run into integral, so let's try it to rotate on x, but I have no clue, you know. Yeah, I can always pick another example. So let's try rotation on x. I really think that this is wrong, because now when you rotate on x, look what you get, right? You get this thingy right there. It goes like that, and it becomes like a little pedestal or something, like with a wide circle on the bottom. It's the bottom of the lamp, right? And then the rest of the lamp is going to go on top, right? So let's rotate around x and see what happens. We need y prime, which is f prime, right, for our problem. That's going to be 2x, x over 2. And we already have x limits, so now we can just stuff everything into integral and see what happens. 2 pi, integral from 2 to 4, because we switched to x. That means it's a dx, which means x limits. Our original function goes in front. That's x squared over 4. And then under the square root, we get to use 1 plus, and then we have x over 2 squared and dx. And yeah, you cannot integrate this in yet. This is a trig sub question. So that's why this is not, yeah, this is going to be a trig sub. Well, at least we set it up. Let's pick next example, 13. Y equals square root of 1 minus x squared from negative 1/2 to positive 1/2 on x-axis. This function given to you is the upper half of a circle of radius 1. So when I draw this, I draw the upper half of a circle, but that's from -1 to 1. They care only about the piece that goes from negative half to positive half, and they're going to rotate that on x-axis. So it creates, right, the bottom piece right there, and then these are sides like that. There will be another lamp piece that goes right here, and then the rest of the lamp goes on top. We're building this lamp little by little in the class. We have a wonderful derivative coming up. It's called the chain rule, where you put 1/2 outside 1 minus x squared to the negative 1/2 times negative 2x as a chain rule. 2 kills 2. Y prime is negative x divided by the square root of 1 minus x squared as a root. All right. S equals 2 pi integral negative 1/2 to 1/2. We use the original function, square root of 1 minus x squared, that's the f of x part, times the square root of 1 plus the derivative squared. And then all you need to do is to just grind through this algebra, and we're done. S equals 2 pi integral negative 1/2 to positive 1/2. Now, I'm going to first take care of the insides here. When I square, I get x squared. It kills the negative. And on the bottom, it kills the root. So it's just 1 minus x squared dx. Now, we are going to use the algebra formula, which you might have forgotten. Square root of a times square root of b is a square root of ab, which means that we can mush these two square roots into a 1 and then distribute 1 minus x squared on each of the two terms. So s equals 2 pi integral negative 1/2 to 1/2. Now I'm going to have, instead of two separate roots, one root, and then I am distributing all of this into 1 and all of that into a fraction. So 1 times this is 1 minus x squared plus, and when I multiply with the second one, they cancel and just give you x squared dx. What now? Cancel these two puppies, because minus x squared plus x squared is 0, and you just have to integrate 1. So the answer is 2 pi. You integrate 1 from negative from negative half to positive half. So you get half minus minus half. So half plus half is 1 times 2 pi. And all right, so let's see one more example. I'm not counting the first one because we haven't done it. We just set it up. See, this is the part when I lied about 15 minutes. It's better to have another example. Aha! X equals square root of 12y minus y squared, 2 less equal y less equal 10 about y-axis. So we can have the y integral as well. What's my x prime in this case, which is f prime of y? Well, we have the same thing. 1/2 12y minus y squared to the negative 1/2 times 12 minus 2y. The half will kill 12, make a 6, kill the 2 over there. So x prime is 6 minus y divided by the square root of 12y minus y squared. Surface S, a surface area, is equal to 2 pi integral 2 to 10, original function 12y minus y squared times the square root piece for the length curve, right? 1 plus, and now I have 6 minus y over square root of 12y minus y squared. Everything squared because you have to square it, right? dy. Two pi integral 2 to 10. Copy the first because you have to deal with the mess in the second integral, in second square root, right? 1 plus, square the numerator. We get 36 minus 12y plus y squared divided by 12y minus y squared dy. Same trick, multiply two roots together to get a single root. Now the whole thing multiplies into 1 and then multiplies into the fraction. Now the good thing is that it cancels in a fraction. So we have 12y minus y squared plus, that's that plus. And then when they cancel, you just get 36 minus 12y plus y squared dy. Ooh. Yeah, I'm bound to someone to ask me, is this what always happens? So no. I've just been lucky. Square root of 36 is 6 dy. So that's 12 pi times y from 2 to 10, which is 96 pi, right? 10 minus 2 is 8. 8 times 12 is 96. So 96 pi. 96 pi units squared, because this is the area question, right? So units squared. as you can see, all you need to do is just a couple hundred of these. Follow the steps of calculation. Both sections are posted on homework. You have the weekend to catch up if you need to with your U sub, especially plugging those limits if you have never done that before, to switch from X domain to U domain and so on, because we'll have the triple substitution eventually. And shoot me an email if you need anything, and stop by office hours next week if you are falling behind and start panicking.